before understanding what are linked lists, let us understand why there is requirement of linked list. And to understand the requirement of linked list, let us understand the limitation of arrays. So we all know that arrays have contiguous memory. It means that the data members in arrays are stored at continuous location. So now what I mean by this is, let me take an example to make you understand this. So let us assume that this is your memory and each box is of a byte. So now if I will declare an array, let's say integer type array whose name is ARR, and the size of this integer type array is 4. So now when I will declare this array, so what will happen in the memory is these blocks from the memory will be given allotted to this array. Now we know that for each integer, the memory required is, for each integer, we require 4 byte memory. And here we have 4 integer, so the total memory that we will require will be 4 multiplied by 4, which is 16. So here I need 16 bytes to store this array, so let me just allot this bytes. So it's 1 2 3 4 and again 1 2 3 4 and again 1 2 1 2 3 4. So here you can see that I have allotted 4 continuous blocks for to store this array. So if I will say that the array that I have here is, let's say 3 8 6 7. So in this first block we have 3, in the second block I will have 8, in this third block I will have 6, and in the fourth block I will have 7. So you can note that arrays have continuous memory location, that is, all the data members of the array will be stored at consecutive memory location. So for example, if this is 100, then the next position will be 104. The next position will be 108, and this position will be 112. So now this continuous memory allocation in the array causes a problem. Now what problem it causes is, so the problem comes when we need to do some addition or deletion from the array. So let me just explain you how this problem comes when we need to add or delete some element from the array. So the array that I have taken above was 3, it was 8, it was 6, and it was 7. So for example, let us believe that here you are going to add some element. Someone has asked you to add the element, let's say 5 between 3 and 8. So now you know that since arrays has continuous memory allocation, so you can't add 5 between 3 and 8 because there is no memory between 3 and 8. So if you want to add any element between 3 and 8, then you need to shift this position. That is, I need to shift this 7 in the next position, this 6 in the position of 7, and this 8 in the position of 6. Then only I will be having space here to add 5. That is, this 7 will be shifted this side, this 6 will be shifted at the place of 7, and this 8 will be shifted at the place of 6, and so on. And so on for if there are more elements between 3 and 8. So now what will happen here after the shift will be done? We will add 5 here, and then 8 will be here, 6 will be here, and 7 will be here. So we have noted that to add element between two elements in an array, we need to shift some elements, and the shifting takes time, so it increases the time and reduces the effectivity of your code. And this shifting is a time taking process. Let us assume that if there are 1000 elements, like it is 3, it is 8, and after it you have 998 more elements. That is, if this array has 1000 elements, and then in this particular array you need to add 5 between 3 and 8, then in that situation you need to shift 999 elements. And if I will increase this number, then the number of elements that you need to shift will also increase. So this is a time taking process, and this is not suggested. You will face the similar problem when you need to delete some element from the array. Let's say now here you need to delete 8 from this array. We need to delete 8. Now what will happen if you will delete 8? Then you will have the array like 3 space 6 and 7. Now again we know that since array has continuous memory allocation for its data, so we need to shift 6 here, and we need to shift 7 here. Then it would be like 3, 6, 7. Again we have noted that here we need to shift 2 elements, and again if there will be 1000 elements, then the number of elements that you need to shift, if 1000 elements are there, then again in the same situation you need to shift 999 elements. Again, this is not recommendable in your code. So now to solve this problem of array, we have linked list. So linked list is another data structure to store the elements. In linked list, there is no continuous memory allocation. We can randomly allot any memory to any data member. So there is random memory allocation and no continuous memory allocation. So let me just explain you this with the help of an example. If here in this diagram I will tell you that 3867 is not array, 3867 is a linked list, then the memory that you can allocate to your linked list can be like, here at this place you can have your 3, here at any random position we can have 8, and here at any random position we can have 6, and at any random position you can have 7. So here you can see that in case of linked list, we can randomly allocate any of the memory allocation. You don't need to allocate continuous memory to your data of linked list. So this is the advantage of linked list. So now let us see that how we will be able to create this linked list and how we will be able to create a link between these elements, because now I have told you that in linked list we can allocate any memory randomly to our elements, but since it is a part of a common list, so there should be any link between these elements so that we can access these elements. So now let us see that how can we create the link between these elements. So now link between elements can be made using the address of the memory where they are stored. So how we will be able to do it, I will explain you in some time. But before that, note that the each element in the linked list is of type node. Now let us try to understand these 2 points with the help of diagram. So I know that here I have 3, here I have 8, here I have 6, and here I have 7. Now we know that these elements are a part of linked list. Since these elements are part of linked list, and let's say the address of first element is 100, the address of this element is 114, the address of this element is 132, and any random address you can allocate for this member also. So let's say it is 157. And now I know that I need to link these elements one by one. So the one way, or I can say the way that we use in linked list to do is to store their address with these elements. That is, when I will have first element here, then with the first element I will store the address of second element, which is 114, so that whenever I will read the first element, with the first element I will be able to get the address of second element, so that with this address I will reach this position. And now when I will read the second element, along with second element I get the address of the third element, 132. Now with the help of 132 I will able to reach the third element. And now when I will read the third element, then along with the third element I get the address of the next element, which is 157. And now here after 7 there is no next element, so here I will store null. So now if I will tell you basic structure unit of linked list, then the basic structure unit of linked list is node. That is, in linked list, to store any element, we used to store data here in a box, and in the another box aside to this data we used to store the address of next element. So if I need to create a linked list, what I will do, I will create two boxes side by side. Here I will store first element. Here I will store address of second element. With this with the help of this address, I will reach the second position. Here I will store the second element. Here I will store the address of third element. Now with this help of address, I will reach at the third position. Now here I will store the fourth element, and here I will store the address of, so here I will store the third element, and here I will store the address of fourth element. Now again here I will store the fourth element, and here I will store the address of fifth element, and so on. And when I will reach the end position, then what I will do, here I will store the element that I have in the end position like 7, and here at place of null, since this is the AND element and there is no element after it, I will store a null, basically a null pointer. So if I will tell you, then you must notice that here I am storing a data, so it should be a variable of type int to store this, and here I am storing the address, and we know that the address is stored by the pointers. So here I will have pointer. Again here this is data, this is pointer, this is data, this is pointer, this is data, and this is pointer. This is basically a null pointer. So this is node. So what is node? Basically a node is a structure which store the data as well as the address of next element, you can say for now. In case of singly linked list, which we are covering today, don't focus on singly for now, because in the next session where we will discuss the types of linked list, at there we will discuss different types of linked list and focus on the singly and doubly. For now, let us understand that node is the basic unit of the linked list, and it used to store data and address of the next element. I hope that this is clear to you. Now again, the next thing that you need to know, that since in arrays we have continuous memory allocation, therefore accessing elements was an easy task in the array, and it takes big O of 1 time, or I can say the time complexity for accessing any element in the array is big O of 1. So now if you will recall, then if you have array like 2, 4, 10, 12, and if you want to access this element 4, then you can simply write array of 1 and you can access this 4. And if you want to access this element 12, then you can simply write array and this mentioning this index 3, you can access this element 12. But in case of linked list, since there is random memory allocation, direct access is not possible in linked list. If you want to access the element, then you must note that only sequential access is possible in linked list. Now what is this sequential access? Let me just take my previous diagram for the linked list. Let's say if this is the linked list 3, 8, 6 and 7, where we are storing the address of the next element, then if you want to access 6, then you can't directly access 6 because you don't have this. You will first come to this first element and then you will read this address. After reading this address, you will reach this second element, and after reaching this second position, you will read this address and then you will reach 6. So if you want to access any element in the linked list, then you need to traverse through all the elements before that elements in the linked list. What I just said is, it means that if you want to access any element in the linked list, then first you need to go through all the elements present before that element in the linked list. That is, if I want to access 6, then first I need to go through the elements before it, that is 3 and 8. Then I will be able to reach 6. And if I want to access 7, then I want to go through first 3, then 8, then 6, then only I can reach 7. Because here I am storing the address, and after reading this address I will reach here. After reading this address I will reach here, and after reading this address I will reach here. So you can note that this is a sequential order that we need to follow if we want to access any element. Now the next point about the linked list is head, or you can say starting element. Now how we will denote our linked list? So linked list will be denoted by a pointer variable named as head. So this head is nothing but a pointer variable. And since this is a pointer variable, we all know that this will store some address. So whose address will this store? So this head will store the address of the first element, which is 100. So if I am creating any linked list, then I will create the head. The pointer variable which stores the address of first element of linked list. So with the help of this head, with the help of this pointer variable, we will be able to access this first element, and with the help of the further addresses we will be able to access the further elements. So here you can note that linked list is basically a data structure, I can say, and another data structure to store the element, where there is random memory allocation to its data member, and the link between these data member is made with the help of the addresses, and the basic unit of the linked list is node. So what is this node? As I have told you, node is basically a structure. This structure where we store the data, and along with the data we used to store the address of the next element. So here I can say that basically node is the basic unit of linked list, where we will store the data value in first box, and in the another box we will store the address of next element. So now how we will create this node in our code? So in C language this node can be created using the struct data type, and in C++ it can be created using the object oriented programming, that is a concept of classes and objects. So let us once see the code for creating the node. So here I will be writing the code for C++, and here I will be mentioning the code for C language. So if I want to create the node in C++ language, then I can use the concept of classes and objects. So the class is node. The functions will be public. The first value will be of type integer, because here I am making an integer type linked list. You can also make your linked list of character type, and to change your type you can change the variable here. You can change type of variable here. If you want to make a character type linked list, then you must write character char at place of int. If you want to make a string type string type linked list, then you must mention string at place of int. So now it's int data value, and there is a pointer which will store the address of the next node, because we know that in linked list this complete structure is called as one node. So this is first node, this is second node, this is third node, and this is fourth node. And in the node itself we have one data and the address for the next element. So in the node I have the data value, and there is a pointer which is storing the address of the next node. Now I will write a constructor which will take int value node star address. Let me first mention the code, then we will focus on understanding it. And the C language we can use struct node int a struct node star address. So you must first focus on these two things, that is the integer type data value and this pointer whose type is node star. So you must note that to store the address of the integer we use int star a. So when I write int star a, then this a is the pointer which stores the address of any integer. Similarly here this next node is the pointer which stores the address of a node. Similarly here this address is the pointer which stores the address of type struct node. So now in the next session we will be discussing types of linked list, and in our third session we'll focus on code of creation and traversal of linked list, and in that third session we will focus on this code in detail and focus and understand these code there in the third session. Don't worry if you have not understand this code now.